So another topic in statistics we have is what's called measures of dispersion. So dispersion, just from a standpoint of a definition, dispersion means how spread out the numbers are. So we're going to be given a set of data, and we want to know how spread out the numbers are. So again, for me, data for me are a lot of times it's sports for me personally. How spread out things are in sports. So again, this is going to tell you how close together or how far apart things are. If the data points are close together, we call that low dispersion. And if data points are really spread out, we call that a high dispersion. So a lot of times, I think of, for some reason here, I think of a gun, a shotgun. A shotgun has a really big spread, if you will, on that. Also, when I work in manufacturing, when we look at the data, we want things to be really, really close together as far as tolerances go. We don't want things spread out everywhere. So it depends on what you're wanting. Sometimes close together is really, really important, and sometimes spread out is really, really important, depending on what you're wanting. So for us in statistics, we're really going to focus on two types, range and standard deviation. So when it comes to range, a range is a simple, quick way to describe how a data set is spread out. So what is it? Range tells you the distance between the smallest and the largest values. So really there's only two data points that we're interested in. Is the largest data point, the largest value, and then the smallest data point, the one with the smallest value. So to determine range is really actually easy. You find the largest value, or we call that the maximum value, and we subtract the minimum value, and that gives us what we call the range. Pretty easy peasy there. So if I gave you an example of 4, 7, 10, and 12, how spread out are the numbers? What I can do is subtract the maximum number and the smaller number. If I could do 12 minus 4, 12 minus 4 would give us a range of 7. If I did that right, nope, actually 8, isn't it? 8 plus 4 is 12. There we go. So, yeah, 8 plus 4 is 12. So 12 minus 4 would actually be 8. So that tells me the range. A lot of times when I think of range, I think of when was back as a kid dating. How young or how old do I want somebody that I'm looking to date to be? You know, uh, so I was in my 30s, so probably, I didn't want anybody younger than 25, and I probably didn't want anybody older than, 45. So want them to be a little younger or a little older, but preferably around my age at the time. But dating is fickle. You never know who your life partner is going to be. So you have these set mindsets, if you will, to start with, and then as you get older, you realize that what you're thinking is you kind of locked yourself in a box. So as we said, a range is really about easy to compute, if you will, and it gives us a little idea of the total spread. Now, the weakness of it all is it only focuses on the front and the end. So if the maximum or minimum value is really out, what we call an outlier, it's really going to mess up our spread, if you will, because if all the other numbers are really, really close together, but the max or min is really far away, that can really mess with our interpretations. So, because it ignores everything in between, it only focuses on the max and the min, and those could actually distort the data if they're extreme values. So there's a pro and a con to the range. Standard deviation is a much more interesting way to determine how things are dispersed. It's a much more powerful way, if you will, and it's more informative. So The standard deviation, typically what it's doing is showing us how far the data falls from the mean. So to do a standard deviation, we first have to determine the mean, which we did in the previous section. So the mean is kind of the average or the middle, if you will. And the standard deviation is how far we deviate or change with respect to the mean. So a small standard deviation, and a lot of times they'll use SD for standard deviation. A small standard deviation means things are really, really tight, close together. A large standard deviation means things are really, really spread out. So again, it depends on what you're looking at, whether you want things packed together or spread out. Like I said, a lot of research, you want the data pretty close to the range, close to the mean. So if I'm doing medicines and things like that, I want things to be really, really close, packed in there with respect to that. There is a formula to determine the standard deviation. So S stands for the sample standard deviation, and the sample standard deviation has a lot going on. So if I read it just as I see here, we have the square root of, and then this is a summation symbol. This means to add a bunch of things together. So X represents the an actual piece of data, one of the data points, if you will, and we're subtracting the mean, but we have to square that. And then we have to divide it by n minus 1, where n represents the total numbers, the total number of items in our data. So it's a very powerful formula because it takes into account all of the data. So it works perfectly with what we call this normal distribution. So it's used almost always. It's important what we call inferential statistics. So it really gives us a way to really look at the data with respect to the mean. Also, it keeps things in what we call the same units of the original data. So if we're talking about a mean salary, if our data is in dollars, the standard deviation is also in the format of dollars. That's very, very powerful. Again, it is also affected by the outlier because the mean is affected by the outlier. It's also hard to compute, unlike the range. So some pros and cons, the range and the standard deviation, you can kind of pause the video and look at that. So notice how they're both sensitive to outliers, but the range is more sensitive to outliers. Notice how the range does not use all the data. Meanwhile, the standard deviation does use all the data, which is kind of important. So the important thing about the standard deviation is it's really spread around what we call the mean, the middle. That's an important thing. Now, difficulty range is very easy. Standard deviation is more complicated, and that's where technology will come into play. We'll show you how to use our calculators or the spreadsheet Excel to do that. So in advanced statistics, range isn't really used as much as standard deviation is. It's used quite often in more advanced statistics. So we have our next question. So we'll put this in our next video.